Dear students, welcome to my lecture. Myself, Dr. R. Arulprakasam, Associate Professor, Department of Mathematics, SRM Institute of Science and Technology. Today I am going to discuss title of the subject is Advanced Calculus and Complex Analysis. Second semester, subject code is 121 MAB 102T. So first I am going to discuss in the first unit multiple integral. So in the multiple integral, I am going to discuss the following syllabus mentioned in our syllabus. First one is introduction. So basically we have to discuss two integration. One is double integral and triple integral. And based on the problem we have to discuss. So also we have to discuss two type. One is what is Cartesian coordinate, how I can evaluate double integral and triple integral in Cartesian coordinate, and triple integral in Cartesian polar coordinate and Cartesian coordinate. These two kind of problem we are going to discuss this section. First, I am going to discuss double integral. So, what is the motivation for the double integral? So, in the schooling level, you studied the function-based problem. Y is equal to f of x. What is the meaning? It's a single variable function. So, y is dependent variable and x is independent variable. You studied in the schooling level. So, what is the differentiation and the integration? You studied in the schooling level. Integration, how we can evaluate what is the rule, the integration in single variable function. In the first semester we want to extend the function more than function involved more than one independent variable. It is called, suppose I can consider two variable function f of x comma y. Z is a function of x comma y. So in the first semester, we studied the topic of function of several variable. You know how to do the function of uh, more than one independent function involved more than one independent variable. Do you know the differentiation? What is the differentiation? Simply we called as partial differentiation. So you know the notation dou divided by dou x and dou divided by dou y. You know, because of here two independent variable involved, so you know how to differentiate. Up to this level you studied the first semester. Now what is the motivation? We want to extend function one variable to two variable. You know how to do the differentiation, so you don't know the integration. The integration we were extending first semester to second semester. Suppose function involved in more than one independent variable, how to do the integration? That is motivation for this topic. So what is, suppose I have the two function involve two independent variables. So how I can integrate? The integration here I have to define f of x comma y into dx dy. This is structure of the double integral. This is main motivation to introduction of this unit. And after that, what is the application? Generally, the application you know everyone very well. The integration is to, suppose I have the area, how to cover this area of the region. This is main motivation to for this integration. The main application is nothing but finding the area of the region. So this is our introduction part of the double integral. So once the introduction part is given, what is the basic definition for double integral? What is the mathematical definition for double integral? So suppose the definition is defined like this. Suppose if the region R is a rectangle given by, so the, because I know you know the two variable function, so function in terms of x and y, the order pair of x comma y, the region limit values defined, x variable and y variable values defined. X value lies between a to b and y value lies between c to d. So here a, b, c are constant, means then they are defined the formal notation of the double integral. Double integral over the region, the function f of x comma y dx dy. What is this? It is very important. Here dx dy nothing but it is order of integration. What do you mean by order? Order is nothing but, so how to cover this region? Suppose I have the region R, the rectangular region, meaning wise it is x axis and y axis. Here x axis and y axis. Okay, so here x value and y value, so x is equal to 0, it is y axis, x is equal to 0, y is equal to 0, x is equal to a. So here they are mentioned a to b, right? So I can suppose I can write, and then it is called x is here, y is equal to, suppose I can consider a and x is equal to a. So it is, I can consider rectangular region. In the region, how to I can cover, this is form order. Suppose I want to, I have to cover this region by parallel to x axis and then parallel to y axis, otherwise y axis. This is the meaning, this is the procedure I have to cover this area. So the meaning is, so just first integrate with respect to x and then y, that this way I can cover. Or dy and dx, dy and dx, what do you mean by dy and dx? The order I can change based on the limit. So what is this called? It is called inner integral, it is called outer integral. What do you mean by inner integral? Inner integral involved in integral with respect to x first, and outer integral involved with respect to, that meaning wise, first you integrate with respect to the variable x, the resultant value, function result integration resultant value, then integrate with respect to y. This is the meaning, define the evaluation of definition of the double integral. So here I clearly mentioned how to evaluate this double integral. So nothing but first integrate, it is I can cover like this, y dx, it is also possible, first y and then x, or first x and then y. What is the meaning? In the function integrate with first with respect to x means we can take x variable limit. What is the x variable limit? A to b. And the resultant value I can integrate with respect to y. This is formal definition defined double integral evolution procedure. So what is the important note here you should concentrate? That here limits are defined constant. Limits are defined constant. So x value lies between a and b, and y value c to d. This is definition of double integral in Cartesian coordinate. What is next? In this slide, I have to discuss the definition. The based on the definition, I can represent it in terms of graphical way. So here x variable limit lies between a to b defined, and y variable limit c to d defined. The definition I have to plot this x and y value. So what happened here? This is x is equal to a is parallel to x axis, and parallel to y-axis. It is line y-axis equal to b is parallel to y-axis, and then y is equal to c, it is parallel to x-axis. So these bounded lines, x is equal to a and x is equal to b and y is equal to c and y is equal to, these four lines covered region. This bounded region is called a region. How to evaluate the area of the region? This is our meaning of this integration of double integral. So what is the next? So here I have to in our syllabus we have to classify three type of problem. What is the three type? First type is limits are defined in terms of constant. That means x value and y value, x variable value and y value always defined constant wise. And another one is, that region is called a rectangular region. Another one is, maybe one variable should be function, another must be constant. Meaning wise, suppose y is function of x, y is function of x, and x must be constant. This is another form of double integral. It is called type 1 in the region. So y is function of x must be constant. This is very important. Note for this definition of double integral. So what is the definition? Suppose R is the region. How they are defined the region? So x and y value lies between x value. Here I mentioned y is function of x. So maybe y is in terms of the function. Maybe y depends on the function in terms of x, and x must be constant defined. So here a and b only constant. Here g of x and h of x is a function. Y is a function of x. So how they are defined this double integral? So in double integral over the region, it is a formal notation of double integral. Double integral over the region function may be defined. Here it is called order dx and dy. So how I can evaluate? Already I told you. Suppose limits are defined constant wise, we can change the order. First x and then y, or y and x. So it depends on the limit. So here in this case, how I can evaluate this type of problem. So one variable limit functionally involved means you should always consider inner integral. Constant value always consider outer integral. This is well defined form of double integral evaluation process. Function, any function is here. Here y is function of x defined. Y is depends on x. So inner integral must be y variable limit, and x must be constant. This is very important. The defined form of the double integral, where limit x limit are constant and y limit is function of x. So integrate first with respect to y and then with respect to x. The procedure we called as order of integral. What do you mean by order? Order means first I have to integrate with respect to x and then y, or y and then x. This is the defined form of the double integral evaluation process. So next I can move on in the geometrical graphical representation of these limits and the region of the integral. So here x must be constant. So x value nothing but x is equal to a, and x here to b. So x equal to a is a line parallel to y axis. Here x is equal to b, it's parallel to x-axis, and I know what is y is equal to g of x, one function, and another function y is equal to h of x. I can consider g of x function. Here I can consider h of x function. These two curve and two lines bounded area. This bounded area is our region of integral. How to evaluate this region? That is application of the double integral. The region may, what do you mean by order? The order means I ought to cover in terms of parallel to x-axis side or parallel to y-axis side. So anyway we can cover, the area value does not change. Okay. Next I'll move on type 3. What is type 3? So type 3 is nothing but the first case I define y is equal to, the first case I define limits are constant. Second case I define y is function of x and x must be constant. Here x and y is a constant form. It is case 1 problem, it is 2 problem, and third problem alternate. What do you mean by, suppose x is a function of y, what happen next? Y must be constant. In this case, these three possible cases is there limit. According this, we should do the problem. This is procedure to how to evaluate the double integral. So suppose in my region defined like this, x is function of y form, x is function of y form, and y must be constant. So this is double integral structure. What is the double integral structure? Double integral over the region. How I can define the region R, the bounded by these two curve and these two line dx dy. How to decide the order? First x and then y. How I can decide? Here look at the x variable limit is involved function of x, or y variable limit involved function of y. I mean x. X is function of y form, or y is here x is function of y form, or y is function of x form. Look at this one. According to this, we have to take this order. Here problem mentioned well, the defined form x is function of y. That means x is function here x value. First integrate with respect to x. Got it? X is function of y. So it is x variable limit and y must be constant. So first integrate with respect to x and then y because of x is function of y form. So y must be constant. So here only these three kind of problem is there in evaluation of double integral. First I define what is the structure of the double integral. Okay, here I have to mention up to this what in the graph up to this I have to mention one second. So here the graphical representation here I mentioned. So here y is equal to c and the y is equal to is a line parallel to x-axis, parallel to x-axis, y is equal to d and y equal to c. It is x is function of y and x is function of y. It is to curve these two curve and this line's covered area is our region. How I can cover evaluate this region value, that is double integral. So here I have to mention few note up to what is I have to mention. First I define what is the well defined form of the double integral. Double integral over the region or here function involved two variable f of x comma y, here dx and dy. It is called order, meaning I explain or dy dx. How to decide this order of integral based on the region. So first problem are the region bounded by limits where x variable and y variable limits all are constant. That means what? X and y all are constant form. Constant form. It is first type of problem. The type is called the region of integral. Region is bounded rectangle region. Constant. Okay. Then what is the second case? My second case is that R is bounded by curve and line. That means what? Here R is maybe first case one, x is function of y and y must be constant. It is one case. Then second one is alternate converse form. Y is function of x and x must be constant. That's it. Only these three case problem we have. That is the it is meaning of here I have defined what is form of the double integral, what is the procedure to evaluate the double integral. In the I explained in the graphical way and notation wise. So now I'll move on the problem. What is the problem here means? First, rectangular region. What is the meaning of rectangular region? Rectangular region I mentioned limits are defined constant wise. So this is our problem. Just look at this problem. What is the function here? Look at this problem. Here, evaluate this. General, what is the general form of the double integral? Double integral over the region R, function of x comma y, dx and dy. It is general form of double integral. Okay. So here function defined. What is the function defined? So in our function f of x comma y. What is the function in the problem? My function is x into x plus y. Okay. So I can simplify this function x square plus xy or like this. We have to do like this. Then what is the next? So this is our function. So what is the region here? My region is defined likewise in my region x comma y. X and y value defined like this. What is the region? My region is x value defined. So how to define? So the limits are constant. So look at this order. What is the order of integral? What is our order? The order of integral. First we have to look at inner integral variable is y outer integral variable is x. What is that means? Here my y variable limit value nothing but it is called a lower limit, it is called upper limit. So y value start from 1 to 2. What is the next outer integral integrating variable is x. My x variable limit is 0 to 1. So likewise, we have to define my region is the mathematically x value start from 0 less than or equal to x less than or equal to 1 and y value start from 1 less than or equal to y less than or equal to 2. This is my region of the integral. Okay, here the mathematically I have to define the region. So in the geometrically how I can define the region of the integral? My region of the integral nothing but so x is equal to 0. What do you mean by x is equal to 0? X is equal to 0 is nothing but y axis. What is next? Next one is x is equal to 1. What do you mean by x is equal to 1? It's parallel to y axis. It is x is equal to 1. Next y is equal to 1. It is suppose it is x axis, it is y axis. So I am taking y is equal to 1 and y is equal to 2. So the four lines covered area is our region of the integral. What is my region? First I can so my region is 1, 2, 3, 4. So this area is our region. Okay, this rectangle is our I split up this here. This is our region. How we can cover this region? According to this order y and x. That means first integrate y and then x. This is our region. So look at this problem. By the definition, first I have to integrate with respect to y in our function f of x comma y. Okay. So just I can take let I is equal to double integral over the region x here function x into x plus y into dy dx. First I have to integrate with respect to x. That means what? Just we can take first inner integral function value. Just I am taking inner integral 1 to 2. It is function with respect to dy. The bracket I have mentioned, first I have to integrate single integral with respect to y. This the result is our outer integral function value. That is the meaning. So if I am integrating with respect to y means you always treat as x is constant. If you are integrating with respect to x means you always treat as another variable y is constant. If I am integrating with respect to x, x into x square is here integrating x square. Here is mistake is there. So it is x into x square. So here some x square. Okay. So otherwise we can treat as it is constant. X is constant. So we keep on x is constant. 1 second. Okay. Just I can solve this side. So integrate with it. This is the splitter form. It is x is constant. We can keep on x commonly. Right. So if I am integrating y, otherwise we can do like this. So x into x is x square, right? I am involving the function like this x square plus xy. 2 okay. So just I am doing like this. So first I am taking inner integral 1 to 2. Here nothing but x into x square plus xy. I am integrating with respect to y first and then rest of the integral. So I am taking this only here. I am taking integration with respect to y. What happened? The x square constant. If I am integrating with respect to y, I am getting y plus the x is constant. If I am integrating with respect to y, what happened? Y into y square by 2. What is the limit? My limit is 1 to 2. Okay, 1 to 2. Here square is missing. Okay, so here x is there in the problem. Here, what is the meaning? They are keep on x is constant. That's they are taken outside here. Here taken outside x is constant. So either we can do this way or this way. Both are equal meaning only. Here they are here for example integral x some 4x into dx like this. Integral cx into dx. What will do if I am keeping c outside x into dx? What is the answer I am getting? C times. So what is here? X into dx, x square by 2. You know this property function involved multiple of c means how we are doing this process. Likewise, if we are integrating with respect to y, we always treat as it is constant. So that's why by the property here constant here mentioned, so I am taking outside constant, so x into dx dy integration value just xy, so y into dy integration value y square by 2. Okay, so either we can go for this form way or this way, both are equal meaning. So here what is the meaning of this? Just I can apply upper limit value and the lower limit value. What happened here? Upper limit value, so if I am applying, whenever we have y, I have to replace y to it is upper limit. So what about here? X, it is y. Y is equal to means x into 2 plus what is the meaning? Here I have I can substitute y is equal to, so 2 times what is the meaning? 2 into 2, 4 divided by 2. It is upper limit by the formula minus lower limit. What is the lower limit value? I have to substitute y equal to 1. Whenever we have y, I can replace y to 1. What happened here? Here I'm substituting x is constant. When substituting y to 1, I am getting 1. 1 into x, nothing but x, plus, so I am substituting instead of y to 1, 1 by 2. This simplified form, what is the simplification form? So I am getting my simplification value. See, so nothing but I can substitute here 2x plus 1. What is the answer I am getting? 2. So 2 upper limit minus lower limit x plus 1 by 2. This simplification nothing but 2x minus nothing but x. It is 2 minus plus 2 minus 1 by 2. It is 1 and a half, right? Just multiply x. What is the answer I am getting? So the simplification form I am getting x into x plus 1 by 2. So here once again here minus, so 2 minus 1 by 2. So it is 1 and a half, 3 by 2. Here I mentioned. Got it. So just I can multiply here inside x into x square. So 3 by 2 into x, 3x divided by 2. So what happened? So inner integration with respect to y is over the resultant function values x square in plus 3x by 2. This is I have to integrate with respect to x. What is x variable limit? 0 to 1. So if I am integrating with respect to x, what happened? X square integration value x cube by 3 plus 3 times x into dx, 3 by 2 constant. So x integration value x square by 2. Already I have 1 2, so nothing but 2 into 2 4. How I am getting 4? So 3x square, the 3 is there. So now I can substitute upper limit value first. What is the upper limit? My upper limit is x is equal to 1. So whenever we have x, I can substitute x is equal to 1. Answer I am getting 1 by 3 plus. So if I am substituting x is equal to 1, what happened? 3 by 4 by the formula, integrating formula minus. I am substituting x is equal to 0 is this lower limit value. If I am substituting x is equal to 0, 0 by anything 0, here 0. So now I can simplify, take LCM. 1 by 3 plus 3 by 4, nothing, taking LCM, just multiply 1 into 4, 4, okay, 3 into 3, 9. So just we have to simplify like this. What is the meaning? So do one thing, 4 plus 9 divided by what is 12. So my answer is 13 by 12. So just here we can do like this. It is best way. So I'm getting answer is 13 by 2. Did you understand this? How to solve this problem? Again, I'll explain once again for this problem. So this is given problem. Okay, this is given problem. So just we can formalize in inner integrating variable is y. Integrate with just we can separate it this first inner integrating structure and integrate with respect to y. We treat as x is constant. The integration formula you know very well. By the formula you are getting answer. So that first inner integrating result is our outer integrating function value. So here I mentioned by the integration I am getting this answer. Followed this I can go for one more problem like this. What is this? It is type. Look at this order. What is the function? Look at the problem. What is the function here? My function f of x comma y is, what is the my function? My function is 1 by xy. So what is the order here mentioned? My order is first dx dy. What is the region? What is the region here mentioned? Look at this problem. Region means here x value. So by x is function of y. Here what is the meaning? X is function of y or y is function of. Here x variable involved. So it is nothing but y is function of x form and x must be constant form. X must be constant form. This is very important. Like this function, I mean region is defined. Y is function of f of x. What is the meaning? Y is 1 to y is equal to x. X value nothing but 2 to x is equal to 4. This is the meaning. So region is defined like this. So in the geometrically how to define, the parabola, I'll explain. So just integration, evaluate the integral. What is the meaning? So according to this, how we can decide the order? How we can decide the order? It is x and then y or y and x. That is very important. My inner integrating variable is y. Outer integrating variable is x. So what is the order? My order is, given order is correct, it's wrong. So my order is, what is the order? First y and then x. Correct. Yes or no? Check it. First integrate with respect to y and then x. So one important things here in the function is multiple form. So by the property, integral f of x into g of x. Okay, f of x is g of x, dx dy is there now. I can separate it. Likewise, integral f of x into dx, integral g of x into dy, g of y into dy. This integral property is applicable. By the integral property, I am doing this problem. Suppose we cannot composition function. We cannot separate this f of x and g of x form in f of x and g of x form. Suppose in our function f of x comma y, I have the function f of x and g of x. It is the composition form is possible. I can integrate likewise. Suppose this composition function is not possible, we can't do like this kind of. So it is some special case problem I consider here because of here function of f of x comma y nothing but 1 by x into y. I can segregate 1 by x into 1 by y. It is f of x form, it is f of y form. That's why here y form, here x form. Just we can look at this x limit and y limit. What is the inner integral? 1 to x. Here 2 to 4. So my integration with respect to y, dy dx nothing but log y, formula. Dx by x integral value log x. Just to substitute upper limit and lower limit, I am getting the result. What is the result I am getting? Log 4 minus log 2. Here log x minus log 1. See, log 4 minus log 2, log 2. So it is nothing but the another property log of a by b. I can write log a minus log b. By the property, I have the right hand side form. I can write left hand side form. Okay. So yeah, here right hand side is there, left hand side I get. So here the log 1 always the 0. So log 2. So it is nothing but what? I can cancel log 2, nothing but log 2 whole square. So here up to this class I explained. So variable limit constantly define how to do this problem. Variable limit function involved. Y is function of x form is defined how to evaluate. So what is the next problem? Do you have guess anything? So the next problem is nothing but suppose the problem define x is function of y form. The same procedure I can follow will get solution. So think this problem. Okay, try to this problem. Note this problem. We'll discuss next class. Thank you, students.